I love this section because it's so puzzly. All the problems that we'll do, you'll see kind of are cool. Not hard mathematically, but kind of like little mini puzzles. They all stem around something called an inscribed angle. An inscribed angle has its vertex on the center, on the edge of the circle here. Therefore, it's inscribed on that. Also notice that two chords make up its sides. The arc that it sits on, to see how it sits on this green arc, is called the intercepted or subtended arc. And you already know a little bit about a central angle. So if I drew in the central angle, you are aware that this angle, whatever it is exactly equal to the arc that it subtends or intercepts. So if this was 100 as a central angle, you would be aware that this is 100 degrees in terms of the intercepted arc. Now here's the cool thing, that the inscribed angle, the guy that's way up there, now you can see he's not 100, is he? He's shrunk quite a bit. He's exactly half of that. So the inscribed angle is exactly half of the central angle or the inscribed arc. This creates all kinds of nice, quick little relationships. So again, the idea is if you knew the arc, I don't know, let's say this arc is 120, you would know the central angle because it's a one-to-one relationship. But the inscribed angle from the same two locations, same intercepted arc, would exactly be half of that. In this case, would be 60. Now that angle, and you'll see in other ones, could be drawn differently. It could be out here. Do you see? That's still 60 degrees over there. Do you see how it's still intercepting that same green arc down here? And so even that would be 60 degrees. I'll show you some examples. Here's a nice little example. If I was to highlight this arc, I actually like to highlight these when I do them. And let's give that a number. I don't know, let's say that's 72, okay? Now, what that means is anybody that goes to the center, nobody goes to the center, but if there was an angle to the center, it'd be 72. Anything inscribed on that, actually this guy is inscribed, isn't he? This guy right here, let's kind of shade him in. This guy right here is inscribed on that arc, so it would be exactly half at 36. Look over here though, this guy right in here, this guy is also inscribed on that same arc, so it's 36. Anybody inscribed, let's grab a new color, this green guy here, this guy right here, it's inscribed on the same intercepted arc, would also be 36. All of that would be true. All of that would be half of the intercepted arc. Here's a cool fact that comes directly from that. Do you see how EF is a diameter, right? Goes through the center. It's a chord. That means that we're 180 out here, right? Now, check this out. This is a cool way to make a right angle. If I create any inscribed angle on that diameter, right? On that diameter, I'm sitting on 180 degrees. So that guarantees that that has to be 90 degrees because half of 180 is 90. So watch this. If I just draw this right here, and if those were straight lines, that would be 90 because it's inscribed on that diameter. I can make endless right angles just by inscribing angles on diameters. All right, 38 here. It sits on this. Now notice that 38 happens to be central. So this guy would also be 38. But do you notice angle 1? Angle 1 is up here, sits on that same arc of 38. But it wouldn't be 38, would it? It would be 19 because it's half of the 38. They both subtend that same arc. One goes to center, it's equal, and the other goes to inscribed. It would be half the size. This guy Kind of unique. Here we are at 114. That means the central angle here, 2, has to be 114. What's hiding in this is the cool inscribed angle in the back. Do you see angle 1? It's inscribed. In other words, it sits on that same arc of 114. But it's not a central angle. It is an inscribed angle. And so it would be exactly half of that, and so it would be a 57, because it starts at the end of that one arc and goes to the other end, so it is half of the intercepted arc at 57. This one has a number of different angles in different places. I notice this one is an inscribed angle, and so I can immediately double that to get 36. That gives me the arc from here to here is 36. I see the 100 here. I see the 134 here. I can actually quickly do a little bit of math by subtracting all of those arcs from the 360. I get a remainder of what's left, and it says that that amount is 90. And so then I can take half of that to get my angle 2, and this angle up here then would be 45 degrees would be its value. There's one final property about inscribed angles, and I really like this. This is called a cyclic quadrilateral, or an inscribed quadrilateral. It gets its name because all 4 points of the quadrilateral are on the circle itself, so it's inscribed. And it's going to tell us a cool fact. It's going to tell us that the two opposite angles, and I'll just put some symbols in here, it's going to tell us that X and O, those two angles, will equal 180. And in likewise manner, it will tell us that the dot, or angle A, and angle C will also equal 180. Here's the cool thing about why that happens. Let's see if I can make sense of it for you by some shading. So I'm going to shade this right here. And do you see that, and I'll call it angle A, the measure of angle A, this guy over here, is exactly half of that grayed or blackout arc. And so it would be half of DCB, right? Because here is the arc that it sits on, so it would be half of that. Now, it would also be true that if we looked at the measure of angle C over on this side, what arc is it sitting on? Let's use a different color. It's sitting on this arc right here. Well, that is 1/2 of the measure of DAB. I don't know, this doesn't seem to be taking us very far, except, take a look. We're half of this amount, and we're half of this amount. Wait a minute. Those amounts were 360 together, right? The blue arc and the gray arc together make 360. So half of this amount, whatever it is, and half of the other amount will always be exactly 180 together. And that's what this is telling us, is that no matter how this is positioned, one of them will be half of an arc and one will be the half of the other arc, and together they make 360, so half of that is 180. So first let's check if it's an inscribed quadrilateral, which it is. All 4 vertices are on the circle. Next, we would recognize that this guy right here and this guy right here would add to 180 together, so that would be 122, right, would be the size of this guy. And let's also recognize that 64 and 1 together would add to 180, and so this would be 116. Let's elevate the difficulty just slightly. Well, the first part I don't think is that tricky, right? The 118 and this angle 2 down here, they would add up to 180 together. So this angle 2, this complete angle 2 would be 51. What is a little more tricky is that what is this angle 1 over here, because this angle is unknown, except it's actually known. How is it known, you may ask? Maybe you didn't ask, but I said that. Take a look at the arc right here. Do you see how that arc sits on a diameter? So what that actually means is that this angle, this inscribed angle, sits on a diameter. So that's not just any angle, that is a right angle, which also means that over here we also would have a right angle, because 90 and 90 equal 180. Plus, I guess maybe I didn't have to go through all of that. Maybe you thought of that ahead of me, is that this is 180, and so this would be 90 anyway, so I actually didn't have to find that, but it's true, it would work out. I love these little guys. They're like puzzles to me. Let's start with something that it isn't required of us, but I think is good. This here is a central angle of 102. What that actually means for us is that this is 102 from here to here. And once I do that, the thing that pops out to me is that angle 1 way up there is inscribed on that same arc, isn't it? And so it would be half of that to be a 51. Now, at that stage, I'm now starting to search for angle 2. There's a couple of ways to do it. I'm going to do it maybe the way that it's expected first. Do you see that this is a cyclic quadrilateral? In other words, all of those points are on the circle. Yes, they are. And what that ultimately means is that angle 2 down here would add with 51 to make our value of 180, wouldn't it? And so it's going to be 129. Maybe let me show you a different way to do that. I'll clear it up and show it to you this way. So let's try this a totally radical way to get angle 2. This is a central angle of 258. That may feel awkward to you, but that is a central angle, and that means that this big arc all the way over here is 258. And can you see that angle 2 is inscribed on that 258? Whoa! And so you could do half of that number. And guess what? Half of that number is exactly what we got anyways. Remember how this was 51, and so these two had to add to that because they sit in the cyclic quadrilateral. What I really love about these guys is there are many ways to get after these answers. Good luck with this stuff.